Out here in the middle of the North Atlantic, Nova Scotians understand the role of time in nature. We mark our days with the tides, our years by the seasons, and our generations by the shifting sands and crumbling cliffs of our favorite beaches. Here in Nova Scotia, we weather the time, and time weathers us. But time has been unraveling forever. What do our current landscapes and ecosystems tell us about what Nova Scotia might have looked like before humans, before the Ice Age, before the dinosaurs, or before that? And if we look that deeply into our past, what can we learn about where we are now and where we're going? We are deeply connected to nature, from old forests to rugged coastlines, the tiniest wonders and vast open spaces. It's where we come from and what we share with all living things. It's time to rediscover the wild. Peggy's Cove is one of Nova Scotia's most visited attractions. But what makes this area most special lies beyond the iconic lighthouse and off the beaten path. The Peggy's Cove Preservation Area is a 2,000-acre coastal barren, and its rare and remarkable geological features offer incredible insight into its past. I'm meeting Dr. Jeremy Lundholm, a plant ecologist who specializes in barrens. He knows this coastal barren very well and can help reveal some of the secrets that this extraordinary landscape holds.
This landscape is so different from other places in Nova Scotia. What is the history that has formed it?
Well, first, we're walking on bedrock, and this is a granite bedrock. These were formed over 300 million years ago under the earth. So magma came up and cooled, and so you get these big pockets of hard granite, and they push through other rocks to be here. And so that's the first thing. The second thing is the glaciers came over, the last 500,000 years of the ice ages and scraped off any existing soil that would have been on here. And so we're left with a lot of bedrock that's exposed. Also, you can see all the boulders, right? See all the boulders that are sitting on top? Those were dropped by the glaciers, so the glaciers were carrying them. And then when they melted, boom, just land. And so that's what we're seeing today.
Evidence of our distant past is often buried deep underground. Here on the coastal barren, it's sitting right on top of the rocks.
So you can see this bare rock right here. Mm-hmm. This is the bedrock. It's been scraped clear by the glaciers when they first came out during the Ice Age, and it's still not vegetated.
Yeah,
right?
There's nothing on it. And
yeah,
it's taken how many years?
Yeah, probably 12,000 or so. It's probably been exposed for 12,000 years, I'm guessing.
Wow.
It's a poor kind of parent material to build soil, this granite. It weathers into sand, and so sand doesn't hold a lot of nutrients, doesn't have a lot of organic matter, and so it just takes a lot of time. So you can see around the edges, vegetation is coming in and soils are building up, but it just takes a long time. We do see a few trees, but it's mainly other plants like shrubs and grasses and sedges and mosses and things like that. Most of Nova Scotia is covered by forest now, so it's a forested biome, but we've got these little pockets that are barren. It's not my favorite term because it's anything but barren. There's so much biodiversity here, and that's why we're standing here today.
Jeremy routinely conducts surveys here, keeping a close eye on some very special little plants.
There's a rare plant in here that every time I come out, I always want to look for it because it's a small population and it's very specialized, so it only lives in one certain area. Mountain sandwort is a fairly uncommon plant species in Nova Scotia, and it's a habitat specialist. It's not everywhere. You have to know what to look for, and you have to actively find it, and it looks different at different times of year.
I still don't really know what I'm looking for.
There it is.
Where?
We got some. We got some right here. This tiny one.
This little one. Oh my gosh, how did you even spot that?
I have always been interested in the natural world, and I spent a lot of time looking at the ground as a kid. And in the 80s, environmentalism was becoming a thing, and that's something that resonated with me. I wanted to do something positive for the planet. Plant ecology seemed like the way to go for me, so that's how it happened. These are actually the leaves, these little tiny green bits. It doesn't get a lot bigger than this. And this is where it will live. It's not going to live on the hard rock like this. It lives in these little depressions where there's a bit of gravel accumulating. And it's not going to live over here in sort of the dwarf shrub area because it can't compete with these guys. It is somewhat rare in Nova Scotia.
I can see why.
Yeah.
It doesn't get along in very many places, and it's so tiny. You need glasses to see this.
Yeah. I'm a community ecologist, so I'm interested in not just one type of plant, but all of the plants that live together in a particular spot, and that sort of defines my field. Yeah, it's wet.
It is very boggy, isn't it?
What I love about these barrens, in particular the coastal ones, is that they're so diverse in terms of vegetation. It's not just one type of plant community, it's a whole bunch that all live together in the same space. We've got wetlands where there's depressions forming, so we have different kinds of bogs and fens. We have little patches of forest, like little tiny forest islands. There's dry, rocky habitats if you just go up a few meters in elevation. And we've got different plants that are associated with those different environments that make up the biodiversity of a site like this. A nice bog, and there's a good chance to see pitcher plants. Here's one right here, this one.
Lovely. Look at that. I've never seen one up close like that.
Yeah, so it's a modified leaf. It's a leaf that is in the shape of a vase, and so it traps water. You can see there's water in that one.
Yeah, it's full of water.
It's living in a very low nutrient situation, so any extra nutrients it can get is helpful. We see carnivorous plants here. Basically, it traps bugs as well, and they will eventually die and provide nutrition for the plant.
Decomposing insects, not decomposing plant stuff.
It's whatever falls in there.
As we get beyond the trees and closer to the coast, the landscape becomes surreal and stunning. Today is a beautiful day, but I wouldn't want to be out here if the weather turned.
We've got a lot of wind, and as you get closer to the coast, salt spray. You know, so all these oceanic influences are happening. And there you can see Peggy's Cove.
Okay, that's a view.
In the foreground is my favorite tree, which is a horizontal white pine. It looks like just shrubbery.
Wait, right there. It looks like a bush.
That's the one. Typically, these would not grow this close to the ocean, but what it's done, it's decided to grow horizontally, basically.
So it has one trunk, like this is one tree.
It's got a trunk tucked back in there, and you can see there's a ridge here. It's probably got cracks. It's got roots finding water and nutrients down there, but you can see what happens every time it tries to go up, it dies back. So there's an earlier attempt that died, and now it's been covered with lichens, and here's a more recent one, and I wonder how well this one is going to do. So, you know, it keeps trying, but it really, to me, I like it because it sort of tells us a story of what barren conditions are like. Lots of wind, coastal effects, probably salt spray, and yeah, not the best place for a tall tree, so. But it's hanging on, and that's the other part of the story, is the resilience of you know, our native flora.
So on the one hand, you could look at this as a stunted, struggling landscape, but on the other hand, it actually represents quite an amazing thing that these plants are so resourceful that they're actually living and surviving here.
It is growing, and it's doing okay.
That is adaptation.
Absolutely.
Right there. Darwin could have saved a trip to the Galapagos. Just come here.
The plants here on the coastal barrens are survivors, adapting over time and holding on strong to make the best out of a harsh situation. And we haven't even gotten to the coast yet. While Jeremy and I continue to explore this landscape, carved by glaciers 12,000 years ago, a few hours north, on the jagged shores of the Bay of Fundy, scientists are studying an ecosystem that existed 315 million years ago, long before these rocks even existed. In a few places along the shores of the Bay of Fundy, Nova Scotia's oldest geological secrets have been slowly exposed over almost inconceivable amounts of time. Dr. Jade Atkins is the curator and director of science and research at the UNESCO World Heritage Site of the Joggins Fossil Cliffs. Jade spends her days studying these cliffs and the fossilized ecosystem that existed on this land 315 million years ago.
Nova Scotia has incredibly rich geology that we don't even think about. The Joggins Fossil Cliffs specifically, you cannot find a better late Carboniferous fossil site in the world. Here at the Joggins Fossil Cliffs, we preserve Pangea, which is when all of the continents that exist today were part of one supercontinent. And at that time, Nova Scotia was at the equator. We were neighbors with Morocco, so we were covered in lush rainforests with huge rivers flowing through, vegetation going right up to the edge of the water. The site at the Joggins Fossil Cliffs is the oldest sort of terrestrial environment ecosystem that resembles today's ecosystems.
The world that's fossilized inside these rock cliffs would have looked very different from our world. But some of it might be a little familiar.
All of the major players that we see today, they were present, or their ancestors were present in the late Carboniferous. So for plant life, we have early conifers, chordates, we have ferns. We have a lot of insects that we still have today. So we have relatives of dragonflies. There's spiders here, there's scorpions here. There's giant millipedes here that are way larger than millipedes you find today. The vertebrates, so animals with a backbone, they're here too. We have ancestors of mammals called synapsids and ancestors of reptiles.
One of Jade's favorite jobs is surveying the beach for new fossils, any one of which might help her paint a clearer picture of how this ecosystem thrived.
This is a tetrapod footprint. So this is a cast, so it's raised up, and there's also casts of little raindrops all around it. When you look at a fossil like this, it's easy to picture a little amphibian or reptile running around in the rain looking for cover somewhere. Or maybe having a nice bath, who knows?
Being able to look at this beach and see a thriving forest within the rocks themselves seems like a superpower. And this place, it feels special.
It feels especially special because every time you come down to the beach, it's a different scene. The Joggins Fossil Cliffs is on the Bay of Fundy. Every day, the tides come in twice a day with the force of a Category 3 hurricane, and they move the rocks all around the beach. And then twice a month for new moon and full moon, we have something called spring tides. And then those tides actually hit the cliffs and help to pull rocks from the cliffs onto the beach, revealing new fossils all the time.
Spring tide was yesterday, so today Jade is surveying the cliffs for anything new. And it's not long before she sees something.
There's a stump in the cliff face right here. You can see that there's a light gray layer, and then there's 3 sections of the stump. These stumps are actually why the Joggins Fossil Cliffs are so important. This is a fossil forest, a rainforest at the equator, and finding the stumps upright in the cliffs like this is what has attracted scientists here for over 200 years at this point. This is a unique fossil site in that the body fossils, so the animals, and the plant fossils, so the plants, are preserved in the environment in which they lived. What I love is that we have this ancient 315 million-year-old rainforest. And if we look over here to another section of the Joggins Fossil Cliffs, you can see the Wabanaki forest, so today's forest, sitting on top of that ancient rainforest. So it's 2 forests, 315 million years in time, separated on top of each other. Here we have Pangea when it's thriving, when it's at its best, and that was a really great time. It was pretty peaceful. Then if you go 40 minutes down the road to our friends at the Fundy Geological Museum in Parsboro, That area preserves the Triassic-Jurassic boundary, which is a time when Pangea was breaking up. And that was not a particularly peaceful time in our history.
A few kilometers south, on the other side of the Cobequid mountain range, the exposed cliffs reveal a completely different time. 115 million years later, and it had become a very different world by then. Regan Maloney manages the lab at the Fundy Geological Museum, and she knows that world well. The cliffs here around Parsboro tell a completely different story than the ones at Joggins.
200 million years ago, where we are now, you would have had to get very used to earthquakes. Because at this time period, what is now the Bay of Fundy was a rift valley. Southern Nova Scotia was breaking apart with Northern Africa, and all of Europe's breaking away. There would have been a lot of seismic activity.
Lava was flowing everywhere as the continents were ripping apart.
This is part of the biggest outpouring of lava that there's ever been in the world. All these cliffs behind me are part of that cooled lava. This basalt here is part of a mass extinction event. And then we have some of the first creatures that made it through this mass extinction event. Here, we're seeing the beginning of the dinosaurs.
Here on Wasson Bluff, a recent high tide has revealed a rather exciting 200-million-year-old footprint.
So this is from a theropod dinosaur. So the theropod dinosaurs are two-legged, meat-eating dinosaurs. One you might be familiar with is Velociraptor or T-Rex. This is probably from a dinosaur we have here in Nova Scotia called Coelophysis. Coelophysis would have been about my size. You can see right here, we're seeing really clearly two of its three toes that often make an imprint. The fossils that we have here in Parsboro are over 200 million years old. A lot of dinosaurs you're probably familiar with, like T-Rex, Velociraptor, Triceratops, they're much younger, some of them even like 68 million years old. So we're closer in age to, T-Rex and Velociraptor than they were to the dinosaurs that we find here in Nova Scotia.
Us humans have only been around for a few 100,000 years, just a flash at the end of an impossibly long timeline. But we do have a special connection to the Carboniferous period. Carbon means coal. And for the last little while, humans have been really into coal.
315 to about 300 million years ago, and then a little bit into the Permian, so a little younger than 300 million years ago. That's where 90% of our coal comes from. This darker layer here is coal. These lush rainforests would die and then turn to peat and then become buried, and with a lot of time, a lot of heat and pressure, it would turn into coal. It's interesting because this coal formed at a time when it was a relatively great environment for our ancestors, but then we moved into a collapse, and now we're burning that same coal and moving into a similar collapse.
Our geology can tell us stories of the ecosystem collapses and extinction events our planet has endured. But it tells stories of incredible survival and resilience, too.
These are little bumps. They are horseshoe crab resting traces. Horseshoe crabs are survivors of most of the historic mass extinctions. This is a great example of an animal that was here at the Joggins Fossil Cliffs 315 million years ago, and then they're still around North America today. The present is the key to the past is the key to the present. Climate researchers who study paleoclimates study the end of the Carboniferous and that rainforest collapse to help us better understand the rainforest collapse we're currently experiencing. And it gives them a better idea of what kind of animals and plant life might be able to survive, and which plants and which animals need more of our help to make it through the drastic climate change that's happening today.
say Nova Scotia is still moving away from Morocco at a speed similar to the rate our fingernails grow. But while the geology of our planet changes slowly, our climate is changing quickly. So scientists like Jeremy are trying to understand as much as possible about how our natural world might handle our future by observing the present and learning from the past.
The understanding is that basically at the edge of ice sheets, you would have had what they call a periglacial environment, and the vegetation around there would have been much like what we see in the Arctic tundra today. The actual coastline, even when the ice was gone, was offshore. Like it was where currently is underwater, right? So the barren environments would have been that way, and they're now flooded, right? And so the barrens would have slowly moved inland, tracking sea level rise, and we can actually see that process is still going on today. One of the things we're looking at now is sea level rise and the effects of sea level rise on different kinds of plant communities. Oh yeah. This is what I wanted to show you here. So this is a great example of what we call coastal squeeze. So what coastal habitats, like a barrens like this, we've got this zone of crowberry, or dwarf heath plants, like low-growing shrubs near the ocean, but not right up against the ocean. But what's happening is, you know, as sea level rises, there's more storm activity, there's more salt water coming in, and you start to see this whole zone where the plants are dying back. They're actually being killed by salt.
So this is like the actual line where the salt water is affecting everything.
But what's happening is another community, the community that, like the lowest zone right by the ocean, these are coming in. Why we call it coastal squeeze is that the crowberry mat, this one here, has nowhere to go. Like it's not going to slowly migrate up. In many cases, coastal squeeze is caused by human development. So a road or a dike or some kind of structure is preventing the landward migration of, for example, a salt marsh.
So this is just a small example of the big picture of what's happening all along our coastline.
Yeah, you can see the tree roots exposed there, and you can see exposed soil. That's coastal erosion for sure. We're here sort of at this interglacial period whereas geologists are predicting maybe in 10,000 years we'll be under ice again. You know, it's that kind of thing. So we're just in this sweet spot where we're able to live in this environment, and the plants are telling part of that story as well, that they're survivors. Yeah, okay, here we go. This is the one I wanted to show you.
Which one?
All right. See down there, right on the point there, there's that little tiny plant. That's roseroot. This is an interesting one. This is one of my favorites. It's a subarctic succulent that lives on our coastline. It doesn't like hot weather, and so that's why it's here. And it lives in rock cracks, basically with no competition from other plants, and this is its happy place. And
right
I love
there,
seeing
all
it.
alone.
You got it.
It's looking pretty lonely down there. I'm gonna see if I can get a closer look.
It's pretty amazing. It's an example of the plants being very adapted to the environment. It's also a unique feature of the Maritimes, especially Nova Scotia, on our barrens, that we have these subarctic species living at sea level. They're right here.
Oh, it's tiny. Looks like a happy one, though.
Yeah, it seems pretty healthy. It flowered earlier this year. You can see the flower stalk on it.
Awesome. I like it.
We're just sitting here in this sort of perfect time for us, but these processes that are hard to see are continue to go on. Plate tectonics, climate change, all of that.
Regardless of what the almost infinite expanses of time have thrown at our planet, our living ecosystems just keep finding a way to forge on. Life seems determined to keep living. It's humbling to consider that all of us, the entirety of humanity, are just a momentary blip in the timeline. Here for a second because the conditions are just right. Here in this beautiful and precious space between our past and our future.
We're going through a mass extinction event today, and it's really being fueled by human activities.
Climate change, the global warming that's occurring today, is causing species to go extinct at a rate as fast as these other extinction events. maybe even faster.
We're in a unique position where we have the power to, if not stop it, slow it down. It's not only about conserving the biodiversities of different plants, animals, fungi, it's also about making sure that there is a future for the human species.
The Earth will live after us. Animals and plants and life will still be here.
Life finds a way.
The Cretaceous mass extinction event was caused by an asteroid impact, but what if the asteroid knew it was going to cause a mass extinction event? You know, that is the power that humans have today.